Everyone, welcome. We solve the equation. We have b cubed plus b squared. This is equal to that 6. Okay, so to solve this equation, we first rewrite it into a standard polynomial form. We are going to write it in standard form such that we're going to have b cubed plus b squared minus 36. This is equal to 0. Okay, now this is the standard. Okay, because this is the standard polynomial form. Okay, and now from there we need to test some of the integers. Okay, we test some of the integers values to find the rational roots. Okay, that will satisfy the equation. So we can start, for instance, we can start with b equal to 2. Okay, so let's plug in b equal to 2 back to our cubic equation, that is b cubed plus b squared minus 36, and check if the answer is equal to 0. Okay, so if we do that, we are going to have 2 cubed plus 2 squared. Okay, this is this is equal to, this is supposed to give us 36. Okay, so if we do that, this is 8 plus 4, which is equal to 12, and 12 is not equal to 36. Okay, that does not satisfy the equation. Okay, and then we can also check if b is equal to 3. Let's check if b is given as 3, it will satisfy the equation. Okay, so that we have, if we have b cubed plus b squared, this is supposed to give us 36. So we will substitute 3. We have 3 cubed plus 3 squared. This is equal to 27 plus 9, which is equal to 36. So that means that b equal to 3. Find other potential root for this cubic equation. Actually, we are going to perform a synthetic division. Okay, we forgot that actually the first root for this cubic equation is equal to 3, and therefore for us to determine the other potential root for this cubic equation, we are going to perform the synthetic division. Okay, such that we're going to have, as you can check this cubic equation, we have that we are using b, that is the first root is equal to 3. As you can see, we have 3, and the coefficient of this cubic equation, we have 1, we have b1, we have 4. There is no b here, but now we can plug in 0, and we have our constant as negative 36. Okay, so now we can drop this one here, so that we're going to have 1. Okay, so if you have 3 times 1, this is equal to 3, and then you perform an addition, so that we're going to have 1 plus 3, which is equal to 4. Again, you see 4 times 3, which is equal to 12. You perform addition sign, so that this is equal to 12, and then we have 12 times 3, which is equal to 36. Okay, so if you see negative 36 plus 36, this is equal to 0. Okay, so these are the coefficient for our quadratic equation. These are the coefficient. All right, so and therefore this is going to give us b cubed, okay, plus b squared minus 36. This is expressed as b minus 3. Okay, b squared plus 4b, okay, plus 12. Let me just write it nicely. We have b minus 3, b squared plus 4b plus 12. Okay, so now this part, this is now the quadratic equation. Let's determine the other root. We have our quadratic equation with a is equal to 1, b equal to 4, c equal to 12. So applying the quadratic formula, which is expressed as minus b plus or minus the square root of b squared minus 4ac divided by 2a. So that we're going to have minus 4 plus or minus the square root of b squared, which is 4 squared minus 4 times 1 times 12, divide everything by 2. Okay, so that now we're going to have negative 4 plus or minus, we have 4 squared, which is 16, minus 48, divide everything by 2. Okay, so that now we have negative 4 plus or minus 16, we have now 16 minus 48, which is equal to negative 32, divided by 2. Okay, divided by 2, so that now we'll have negative 4 plus or minus negative 32 can be expressed as, this is 16 multiplying by 2 multiplying by negative 1, divide everything by 2. Okay, now we are going to have negative 4 plus or minus square root of 16 is 4 multiplying by square root of 2 multiplying by, now the square root of negative 1, this is equal to I, so that we multiply with I, divide everything by 2. So this is equal to 2 plus or minus 2i square root of 2. Okay, so that means that implies that x2 is equal to 2 plus 2i square root of 2, and x3 is equal to 2 minus 2i square root of 2. Okay, and remember we end that our x1 is equal to 3. So in this case that we have 3 solutions. We have the real root. Okay, we are saying that we have the real root, which is equal to x1, which is equal to 3, and x2, which is equal to 2 plus 2i square root of 2, and x3, which is equal to 2 minus 2i square root of 2. These are complex roots. Okay, we are saying these are complex roots. These are complex roots, and those are the solutions for our equation. Okay, for our cubic equation. Thank you for watching and kindly subscribe.